to the Tech Ed Podcast. We are nearing the finish line here at Automate. We've been live streaming all week with a series of absolutely incredible guests. It's been a wonderful week. All the technology, all the amazing advancements and innovation. I can't explain, and if you're not here, you're not one of the 25,000 people that have come through the doors here over the course of this week. It's impossible to explain how amazing the show has been. It's the largest gathering of automation professionals in North America, and you can feel the energy, and we have all week. We're finishing strong. It is going to be a phenomenal afternoon for us. As everybody knows, we have been live streaming all week from the FANUC Education Pavilion, and we have told you all week that FANUC is the largest producer of robotics and CNC controls on the planet. We've talked a lot about robots this week. We've had folks like Lou Finazzo, Mike Chico from FANUC. We had Jim Cooper from FANUC talking about automation, talking about robotics. We haven't touched quite as much on the CNC side of things, and that is what we are going to do for the next 30 minutes with the gentleman who runs the education program for FANUC on the CNC side across the entire North American continent. His name is Joe Baldiga. He is the CNC Education Program Manager for FANUC. And Joe, it is awesome to have you with us. Thanks for joining us.
Oh, it's great to be here, Matt.
So you have had an incredible couple of weeks, as you and I were talking earlier this week. You are coming off of this incredible trip to Japan for the private show. So tell our audience a little bit about, here's the question I want to ask you. How many years have you been at FANUC?
So this week it's 22 years.
22 years, so more than 2 decades. 2 decades plus 2 years that you've been an amazing FANUC team member. First trip to Japan, if I'm correct, right?
Yes.
I want you to tell us about that moment that you walked onto the campus outside, 2 hours outside of Tokyo, and zipped up that yellow jacket for the first time. Tell us about that moment.
Yeah, I think even before then, just the flight over there. Usually people are like, "Oh, try to sleep on the flight," and there was no sleeping for me.
Right.
I was ecstatic. I was so thrilled. So in addition to working for FANUC for so long, I also took Japanese in high school and in college.
No way.
So it's kind of a lifelong dream to go to Japan, and then to go with FANUC made it all the more better. And so when I got there, and that morning when I zipped up that yellow jacket, I was like, I kind of got a little verklempt, as they used to say, like, wow, this is it. This is the moment. And wow, when we arrive there and you see this literally a small city of yellow massive buildings. We got in there and we saw they do an exhibition of new products and new technology on the floor, and it was just so much innovation just in that small space. And then the factory tours were just mind-blowing.
Isn't it incredible? I've been really, I don't use this word lightly, blessed to make that trip twice over the course of the last 6 or 7 years. And it's as much as Automate is hard to describe to somebody who isn't walking the aisles of this incredible show, it is impossible to describe the feeling of being not just in Tokyo, which is a beautiful city. The people are so nice, perfectly clean, everything running on time. I mean, it's an amazing place to be, going up to the top of some of the buildings and just looking out at a sea of humanity and, 30-story buildings that look tiny when you're at the top of it. It's impossible to describe without experiencing it, but I'm going to do my best to try. You get out to the FANUC campus, you're on the bus, you're looking out the window, you're that you're on the campus. First thing is that this is not like some big cement playground, right? It's not a concrete jungle, as they say. I mean, one of the things that I know that FANUC is really big about is making sure that you can't see one building from another. It's like you're driving through a forest, a beautiful forest, and all of a sudden a huge manufacturing facility pops up. So I'm assuming you got to ride the bus in and do all those kind of things. Yeah. What was that like?
Oh, I think the sort of the apex moment was seeing Mount Fuji in the distance, and as you get closer, I think from the photos, it looks smaller when you see it, but when you see it in person, it's a legit mountain.
Yeah,
it's 14,000 feet high.
Yeah, and they're by itself too. I mean, yeah.
Yep. So and then the campus, like you said, it's really surrounded by nature. Beautiful place. So they really do a good job of embracing not only the industrial side of things, but also incorporating nature and not being too invasive into that space.
Absolutely. And it's such a great experience. Anybody that ever gets an invitation to the private show, don't ever turn that invitation down. I would describe the experience as life-changing. We had Craig McAtee on with us earlier today, who was on the trip recently as well. And not last week, but some years ago, 2 or 3 years ago, and said the same thing. He said, literally, it's a life-changing experience. Do you feel a little bit like that?
Yeah, I mean, you hear about it from other people who went, but then when you walk into a factory that they're literally making 15,000 120,000 robots a month.
Yep.
That's the capable, and it's robots building robots.
Exactly.
So a big giant R2000 is picking up a small, M8 bolt and inserting it, and they're using vision to find it and force sensors to mesh the gears together, the technology, and then the understanding the complexity of what's involved with it. It's like if you see somebody who's maybe a good ballet dancer or opera singer, and if you you understand how hard it is to accomplish that high level of skill, and then you see it on display and you understand that difficulty, you can really appreciate it all that much more. I mean, the motor factory was 120,000 motors a month.
I know, it's just insane, right?
And that's the core of our technology we're really good at servo motor control, everything from these small 0.2 beta motors all the way up to huge motors that are very capable.
Yep, it's absolutely mind blowing, and it's a great experience. And we're talking about robotics here and automation, in as much as we're at Automate, and it's not just the FANUC booths where you see FANUC robots. It's everywhere we go that we're seeing FANUC robots, and so many of the integrators and so many of the OEs that have really cool applications for automation and robotics. We see those everywhere. You certainly saw those when you were in Japan. But sometimes people forget that the genesis of your company, FANUC, wasn't robotics. It was CNC controls, right? Tell us a little bit about that.
Yeah, really. I mean, the robots are the large flashing object, big yellow arm moving, lifting a big Corvette, and then over in the corner is this high-tech 5-axis machine that's doing, very tight tolerance, high speed machining. So really FANUC's origins, the mid 1950s. Dr. Inaba took an MIT study that he had heard about, and we were part of Fujitsu at that time, and he had a ragtag group of startup engineers and said, hey, this has commercial viability. On the first NC controls, and they productized that in the later part of the 1950s, and then as computers came about, it became CNC controls. And then from there, we really, like I said, servo motor control is our forte. And we took that and we built out the entire, product line. And that's really all a CNC machine is. It's servo motors that we're controlling, mechanical connections and moving through space. And the robots are the same way. But robots get a lot more attention because they are they're the attention hog, flashy object. But CNC is pretty darn cool also.
No question. You guys doing the heavy lifting on the CNC side, figuratively, in terms of FANUC's background. The name FANUC actually has its origin in the CNC control. Is that right?
Yes. So it's actually an acronym. You'll notice it's always capitalized. So it's a Fujitsu Automatic Numeric Control.
Interesting. So. Yeah, absolutely. So that's the genesis 70 years ago. I mean, you think about the 1950s, that goes back a ways. FANUC now, I know I'm correct, but the largest CNC control producer on the planet. You've got way more than 50% market share. I don't know if you're at liberty to say exactly what it is, but huge market share in this space, not just on some of the FANUC branded solutions like RoboDrill, RoboMachine products, but in terms of other machine tools, really ubiquitous in terms of companies adopting the FANUC platform in their machine tools, correct?
Yeah, correct. So a lot of times they'll buy our CNC as the brain of their machine, and then our motors to be the muscle of the machine. And we have thousands of machine tool builders, across the world. And as you said, we do have the lion's share of the market in both CNC and robotics. We've produced 5.2 million CNC controls.
I mean, think about that. 5.2 million. I mean, that's insane. 5.2 million. Yeah, no, exactly. It's absolutely mind-boggling, and never obsoleted a product either, which is one of the things that impressed me about my trips to Japan, going into these huge inventory warehouses with components that are literally, in some cases, 50, 60, 70 years old, telling stories about if a supplier is going to obsolete a component, FANUC buying the inventory of that, so that if you have a company or a partner that bought a FANUC control 20, 30, 40 years ago and has a failure for whatever reason, and sometimes the meantime between failures can be that long, they have the ability to go back and keep that product up and running because you've got the components.
Yeah, on the tour we saw test benches that were for equipment that was manufactured in the 1970s.
Yeah, it's incredible.
And the other thing I learned is they also, in Japan, they try to forecast potential usage down the road and will stock up on those materials to make sure. So already planning ahead. That's really why FANUC wasn't hit so hard with like the semiconductor issues, is we already had a pretty large supply that we were able to tap into until we were able to come up with some alternatives.
Absolutely. I think your president and CEO's comment yesterday when we were having a conversation about some of the supply chain challenges was, when we say we have to go back to the factory and get the product, we are the factory. And so we have to go back to ourselves and make sure that we can keep the product flowing, and having that inventory and that planning and the production capacity, certainly in Japan, and paint production capacity on the robotic side here in the United States, was one of the things that helped FANUC weather the storm through the last several years, which have been crazy. The other challenge that our economy has faced, especially in manufacturing, the shortage of talent. As you can imagine, every single guest that we've had on the Tech Ed podcast this week, one way or the other, is touching those challenges, is feeling the challenge of not having enough individuals to help automate their process, to help integrate technology. Tell us what you're seeing on the CNC and machining side. Are they having the same challenges in that space?
Yeah, certainly. When you look at us being the dominant control and really the industry standard control out there in the market, there's a skills gap for sure. And we're starting to change and do a shift from a college prep sort of model in the school system to being more accommodating to career options and exposing students to careers, and becoming more acceptance of students going into the trades, and not look down on if they're not going out and getting a 4-year degree. So there's definitely a need in the market for talent. Particularly in the machining side, we look at the average age of a CNC machinist is 47 years old.
Wow.
And that's the higher end of that scale is the older talent.
Right. That's why your experience and all your knowledge and wisdom is. Yeah.
Yep. And then the problem is that the age groups that are below that are not, there's not enough pipeline to fill that gap. And now we're also seeing with, post-COVID situation, a lot of direct foreign investment that's happening here. So more companies are investing, as well as a lot of reshore and bringing manufacturing back locally. It puts a big crunch on the talent pool and where students are going to be coming from and where we're going to be finding people. So it's good from a standpoint for the robotic side. Where companies are trying to automate more processes and maybe add a robot to do that tending, but you still need, machine programmers. You're going to need those operators, and those operators need to be higher level of skill from the standpoint to potentially be working with a robot, working with the CNC control, and understanding how they all work together.
Absolutely. Are those the main career pathways? You've got machinists, you've got operators. What are some of the other career pathways in the world of CNC machining?
Well, you can get into maintenance technicians. One of the nice things about the working in CNC is you can start off as a button pusher and work your way up. So you get in there on an entry level position, and if you have, you can go to school at night, get an apprenticeship program, upskill yourself, and then move up to potentially a setup person, a setup 2 person, and then get into where you actually become the programmer, and then get into 5-axis programming, which is even more and more in demand.
Right, and probably along the way, higher paying, even more interesting, more challenging, higher skill jobs. Right?
Certainly.
Yeah. Absolutely. So how is FANUC now engaging with the world of education to help generate this next generation of talent?
Yeah. So in the past, because FANUC is a very reliable, robust control that's industrial grade, and oftentimes with industrial grade products, it comes industrial grade pricing. Well, sometimes that isn't very conducive to education. Education does have limited budgets, and and it can be a challenge from that aspect. But as technology advances, costs do come down. As well as there is the growing need from industry causing that demand and the push. A lot of our major customers are starting to talk to schools and saying, we need this type of skill set. We need to have that correct pathway from the classroom to the factory. And FANUC hears that, and we're coming out with a lot of different solutions, whether it's using our NC Guide, which is just a PC-based control simulator. We have our CNC simulator, machining simulator, and then recently, we announced we have a partnership with Bantam Tools, which is a small desktop.
Yeah, we'll get into that in more detail in just a little bit.
And then we have LaVille EDU Mill, great small, compact, robust machines manufactured out of Florida, all the way up through DN Solutions, Robo Drills. So we've tried to create a good portfolio of options for schools to address that skills needs.
Absolutely. What are some of the challenges you run into, Joe, in terms of getting new educators on board, getting them excited about the technology? I know you've got a national group of education solutions providers that are working really hard to advocate for FANUC, and you would think that the path should be relatively easy. You're the largest machine control in it's not just in North America but around the whole globe. So what are some of the hiccups that you run into in terms of making this technology more ubiquitous in education?
Yeah, I think oftentimes I think in the education space they don't necessarily understand what's happening out in industry, and in addition to that, how they could utilize this industrial equipment to teach concepts throughout, the development of the students.
Right.
Cartesian coordinates, X, Y, Z plane.
Yep, right.
I remember being in school and going, what am I ever going to use this for?
Yep.
But then you look at a CNC control and it's X, Y, Z, it's all the motion.
Right.
Oh, now it makes sense. Now I understand. So you could use this technology in the classroom, but there's that gap in the skills gap is the knowledge between academia and industry on how do we work together and how do we apply this. Other aspects of it, there are, ways to teach G code and programming, and you could do it on, a lower cost PC based control or some other brand control, but it's not a direct translation to what is on the factory floor.
Right.
So a student might learn, I learned a little bit of CNC programming, or my dad has a CNC wood router in the garage. So we worked on that a little bit, and that's a good starting point. Sure. However, it's not going to be that direct translation into an occupation in a true career.
Absolutely. To put this into perspective, I won't name the college, but I interviewed somebody a year or two ago who was pretty involved in the CNC space, and their students, they had a number of students that had learned CNC machining on a control other than the FANUC control, and of course then they get out into industry. And they say, 66% or whatever, 2/3 of CNC controls are FANUC. That's odds on the one that the student is going to run into. And that other 35% is pretty bifurcated too. Lots of different players in that space, right? So by and large, they're going to see the FANUC control way more than they're going to see any other kind of control. And I challenged that dean a little bit and said, look, your students are learning on a control different from what they're probably going to see in industry. And he said, yeah, but, it's the same code, and I'm told that it translates pretty well. And I said, well, maybe you should ask some of your students that have gone through your program and have gone into industry and have worked on other controls, and just let them tell you what they think. How easy was it to make a transition from the control they learned on while they were in that particular college to when they got into industry? And he was shocked. He actually came back to me about 4 months later, and I think he expected them to say, it was no problem, and you could pick it up within a couple of hours. And the average range was, they said, there were transferable skills, and what we learned on that other control, we could translate into what we needed to do on the FANUC control. But it was a good 40 to 80 hours of learning for those students to get themselves to a point where they felt comfortable navigating and programming on the FANUC control after having learned on something else. That's a pretty big gap. I mean, when you think about a machining program and the number of contact hours in machining, to have to go another 40 or 80 hours to be able to use the control you're going to use when you get to industry, isn't it easier to just train them on that control?
Exactly.
Or at least expose them to it? I mean, it doesn't mean to be 100% FANUC necessarily, although I'm sure you would like that, but to make sure that they're getting exposure to the FANUC controls. You've got so many ways to do that, from the simulators. You talked about some of the smaller machine tools, desktop machine tools, all the way up to, full-on, highly precise robo drills and everything in between. You touched on just a moment ago this new announcement that you just made recently about a new partnership. I want to dive into that a little bit. So and it's really, really exciting news. Let's talk about that and tell us what you're up to.
Yep. So at this past IMTS, a guy came down to the student summit, and I looked at his shirt, and he had a small little chicken on it. Okay. And I said, that's the logo for a company called Bantam Tools. Yeah. And they make a small desktop CNC with their own PC-based control, and good quality little robust machine that cuts metal. And we got to talking, and some other people got involved and said, well, what would you think if we were to do something where we took the FANUC Education Simulator and a modified version of it that does have motion capability, and then hooked it up to your machine, put our servos on it, and then we could use this as a training tool that's low cost, easy, reduces that barrier to entry to get students trained on FANUC controls in the classroom.
So the simulator that you're mentioning, just tell our audience a little bit about it. I certainly know what it is, but explain to them what you mean by a simulator.
Yeah, so basically it kind of looks like a suitcase. Okay. A suitcase sort of giant calculator. Okay. But really it replicates a FANUC control that would be used on a larger CNC machine. Okay. And it's meant to just train students and get them oriented to how to navigate through the FANUC menus, how to enter in tool offsets, work offsets, how to load programs, how to modify parameters. So it is a functioning FANUC control without motion capability. Got it. So it can't drive actual CNC motors. Otherwise, all of our machine tool builders would buy the low-cost simulator, put it on their machines, and run them. So in this case, we basically took that same case, but installed a real actual motion capable CNC inside of that desktop unit to make it nice and compact It runs on one, standard standard wall outlet power. So it makes that easier. So you don't have to get special power requirements, riggers. You can actually have a full FANUC CNC machine for a very low cost.
Absolutely. So will it function as a simulator as well?
It's going to be mostly just a machine.
Okay,
for this
got it. So so you've got now this what used to be it still is a version of the FANUC simulator. It's got the same soft keys and hard keys you would see on a FANUC control. So you walk up to a FANUC controlled machine tool, and it looks exactly the same as what a student would see when they walk into a FANUC facility using FANUC controls on their CNC machine tools. You've got peripherals that are connecting that to the Bantam machine tool, and it's actually operating that machine. I understand that, right?
So we put our drives in the base of the machine. So in our small FANUC servo motor, so it's a closed loop system. The spindle's still open loop. It's a 28,000 RPM spindle. ER11 collet, so 1/4 inch bits up as maximum size.
You're talking like a CNC guy.
Yeah, so we're able to rip some good material, and it cuts aluminum. Which is different than other desktop units that are out there on the market.
Sure.
It's optimized, in fact, for aluminum processing. So good for education space, as well as if you're an engineer wanting to do some rapid prototyping or just mock up something real quick. It's almost like the equivalent of how additive, 3D printers became very popular to be able to mock up something quickly. You have now the ability to, all right, let's just cut it in aluminum and be done with it.
Absolutely.
But it'll do other non-ferrous metals, copper, bronze, softer metals. You could potentially do steel, but it's not supported.
Got it. Okay.
Yeah, so we don't want to
don't want to recommend that.
We don't recommend that. Wood's possible. There's vacuum attachments, so it should be a nice setup for the education space and a great addition to the already nice portfolio that we offer to education.
Absolutely. Well, and there's a couple things that I love about it. You can tell me if I'm kind of hitting this right, but if you think about a FANUC robo drill, which every high school should have a FANUC robo drill, right? Not every high school has the $50,000, $70,000, $90,000, whatever it is, to invest in that type of equipment. Although some do, which is really, really cool. If I'm a high school, maybe I'm a technical college who wants more of my students to have hands-on experiences with the CNC machine tools, I'm limited in my budget to be able to have a gigantic facility that's filled with $50,000, $100,000 machines. It really allows a student to get their hands on the industry-leading machine control, and lots of students to do that in an environment where the price point is hitting maybe an education price point, a high school price point, a career center price point. Am I getting that right? So you're getting the combination of industry-grade material, this amazing machine control, and obviously the Bantam machine being able to cut non-ferrous metal. Obviously, great experience as well. But you're doing that at a price point that makes sense for education.
Correct. And I think the other side of it too, that maybe we don't talk about that much, is that it takes away that fear factor and intimidation factor.
Sure.
If you walk up to a large machine tool and you're like, if I do anything wrong, it's going to be expensive.
Right.
It's going to be loud. And it's a small but mighty machine.
Yep.
So I think it takes away that intimidation factor for students.
I've been called the small but mighty machine a few times in my life as well, in different contexts. But I can certainly relate. So you've got this industry grade machine that is accessible to all these students. We talk a lot of times about using things like augmented reality, virtual reality, teaching, for instance, students to weld. And that's one of the things that we talk about is, you can take a student who might be intimidated by, in that case, getting into a weld booth, putting on a helmet, actually laying down a bead. I mean, if you haven't done that before, that can be a little bit scary and maybe discourage people from doing it. Here you've got the same thing where, who could be afraid of something called Bantam with a little chicken on it, right?
Yeah.
I mean, it's very friendly in that sense, but it really is a true industrial machine tool capable of cutting metal and so on.
And it is actual cutting. It's, not simulation. The guy Ron from Bantam here we were talking about simulation. He goes, oh yeah. He goes, I've got thousands of hours on a flight simulator at home.
Right.
You feel comfortable with me flying you to Florida?
Exactly.
And I was like, no,
yeah, exactly. You need to get the hands on. My wife, Renee, and I actually joked with her. I have the space shuttle flight simulator on my iPad, right?
Okay.
And it's the simulator that, in order to be an astronaut, you have to fly 1,000 missions on the flight simulator in order to, as that's part of your training. And I had flown 500 missions on the flight simulator, and explained to my wife one night that I don't know if she realized it or not, but I was actually halfway to being a space shuttle astronaut, having flown 500 missions. And I'm guessing there might be a little bit more to it. Kind of the same analogy here on the simulation side for CNC. What early adoption and what kind of feedback are you getting from the market about this new opportunity?
I think we debuted it last week at East Tech, and there's a lot of excitement. So a lot of schools, as well as, like I said, industry people wondering about, even training incumbent workers.
Right.
We're bringing on. There's so much workforce changes and people changing roles, seeking out new opportunities, or trying to upskill existing talent. This presents an opportunity for even manufacturers to train their employees that are on their floor, instead of actually taking the production equipment down or offline, or
That's a great point.
or putting it at risk. Here's a safe way for us to train up the workers.
Absolutely, yeah. I mean, we think about it as an application for education, really, really important. We also talk a lot on our podcast about the fact that if you turn the clock forward 20, 30 years, most of the people that are working in manufacturing in 20 years are already people working in manufacturing today. And so, in as much as we talk about the importance of inspiring young people toward their careers in advanced manufacturing, giving them the skills that are necessary when they get there, the truth of the matter is, equally, if not more important, is upskilling the incumbent workforce, people who are already working, in this case, in a contract machining company or in an OEM that has significant machining capabilities. They've got new people coming in all the time. Those individuals need to learn machining. You can do that one of two ways. You can take them out to a machine tool that they might be intimidated by, that, oh, by the way, we need the capacity for production, that in that they may be in a position to run a tool out of a machine path and create downtime and all these other headaches that can come along with not operating a machining center in the right way. And instead of doing that, you put them in a lab. They've got something like this solution that we're talking about here, and now we can train an incumbent worker as well. So you see a market for that too.
Definitely, yeah. And I think it's the best thing a company can do for their employees.
For sure.
Just try to, if you've already got them there, they're already familiar with your company's culture, already probably safety trained, gone through some of those. Now, all right, let's give you a bit more responsibility. You've proven yourself, and I think it's a great way to not only for traditional students and getting them interested in manufacturing, but upskilling existing employees.
Absolutely. So let's talk about what else is on the horizon for FANUC, especially on the CNC education side, Joe. I know you're looking at potentially a new credential in partnership with NOCTI. I'm not telling stories out of school, and Gilchick was on with us earlier this week and teed that up a little bit. So what has you excited about that?
Yeah, so that is pretty exciting. Trying to get a nationally recognized credential and endorsement on precision machining. So we're working together with some some industry experts to look at doing the job task analysis, and going to be working on coming up with a FANUC NOCTI certification in precision machining. We currently do have a CNC certification through FANUC, but we want to have that third-party endorsement so that it does become legally defensible instead of us just self-credentialing students. So we do have the opportunity for people to go through, train an instructor. Students can use our curriculum and e-learn materials to help train the students, but we would like to have a way to make that legally defensible and have the students take a test from a third party. And that's in process right now, and I think it's going to be pretty exciting.
Yeah, for sure. All this innovation taking place, whether it's on the hardware that we're using to train students around manufacturing careers, in this case CNC machining, or the credentialing side, which is huge. And half the guests that have come in have talked about the importance of third-party credentials. We're continuing to see those grow, sometimes as an alternative to a degree program, oftentimes in concert with a degree program.
Exactly.
So lots and lots of opportunities there. Anything else that you're, as you look, here we are in, hard to believe we're almost closing in on the end of May of 2023 already. As you look through the rest of the year, Joe, what are you most excited about on the CNC side for FANUC?
I think I'm excited to see how this takes off, but I think there's going to be just a more resurgence in getting students engaged, and that's really what my role is. I love just the engagement with students and letting them know and exposing them to these potential career opportunities, whether they decide to go with the flashy robots, or they want to learn CNC, or they want to be a super tech and do both. Like that's a critical part right now.
Sure.
A lot of these manufacturers, they're struggling to find workers and operators. a great opportunity is to add some automation to it.
100%.
Well, we have to have somebody eventually, a technician that's going to be able to troubleshoot the CNC machine,
Absolutely.
the robot, what's going on, how do we integrate the two of them together. And I think that's probably the next step is what can we do to help create a curriculum or tools to do more integration of robots to CNC machines.
Absolutely. Super, super exciting times for FANUC. It's going to be a great finish to 2023 in the 7 months we have remaining. We have probably 7 seconds, maybe a little bit more than that remaining, but we're nearing the end of our time here, Joe. I want to ask you one last question that we love asking our guests here on the Tech Ed Podcast. I want you to turn the clock back before your trip to Japan, before your 22 years at FANUC, before your time in the arts and so on, and go all the way back to high school, your sophomore year, give or take. You're a 15-year-old kid, your whole life ahead of you. And if you had one piece of advice that you could share with that young man as a 15-year-old, knowing all the things that you know now and the amazing routes that your career has taken, one piece of advice, what would that piece of advice be?
Well, I actually brought my kids to the show.
Awesome.
My daughter's 15, my son's 17.
They're here.
Yep. So I would have told my 15-year-old self, listen to your dad.
Yeah, there you go. And what was your dad telling you that you should have listened to?
My dad told me that I should go into robotics.
Did he really?
Yeah. Well, he actually, in 1994, they got their first FANUC paint system. So he was a skilled trades electrician with Chrysler.
Oh, nice.
And he came home and was talking to me about the technology and the capabilities of robotics and how nice the facility was, and somehow that planted a seed in my brain. So I was interested in it. It took a while for me to circle back toward it, but I did actually listen to my dad, and I'm very grateful I did.
I'm going to argue things ended really, really well. I mean, you're doing just an incredible job of being this awesome ambassador and advocate for careers in CNC machining, working with all kinds of incredible people. I see every week I see another notification pop up on LinkedIn that you're with another educator, inspiring another group of students toward another group of incredible careers. So I want to thank you for your advocacy and your leadership, Joe. It's been fun to watch. It's been wonderful to partner with you, and especially thank you for spending some time with us today on the Tech Ed Podcast, talking about all the great things you have going on.
Thank you, Matt, and I want to reciprocate that and all that you do for the technical education market and this podcast. I'm a huge fan of it.
Thank you very much. It's been an honor to be a part of it, an honor to be in the FANUC orbit. I feel incredibly blessed and just really appreciate your time.
Thanks, Matt.